In this training, we're going to be taking a look at creating a 2D platformer with a special emphasis on the character controller. We're going to be using a couple of assets, some from the 2D platformer project, which we released when we released the 2D tools. I'm going to walk you through the main character controller script for that, through a simplified version of that, and we're going to spawn some platforms, and we're going to have some coins as well. So let's start by going to the asset store and importing the stuff that we need. I'm going to walk you through this on the stream. Sometimes I like to import stuff in advance, but I figure this is worth walking you guys through. So the first thing that we're going to do is we're going to search for 2D platformer and grab the 2D platformer from the publisher Unity Technologies. Click the import button. Now notice it says here we're importing a complete project and that it's going to overwrite our current project settings. So this is going to affect things like tags and layers. There are actually some layers that we need to use for this project, so we want this to happen. Note that I'm doing this in an empty project, so that's important. So we're going to hit import, and it's going to pull up our import dialog where we can choose what parts of the project we want to import. Now, we are not going to bring everything in, so we're going to start just by hitting none, and then we're just going to choose the folders we want. So we're going to want the animations. We're going to want the animator controllers. We can skip the audio. We'll bring in the project settings because we want to set up the tags and layers. Really, it's just one layer. We can do this manually, but we'll bring that in. We don't need any of these materials. We do need the physics materials. We do need the character prefabs. Really, we just need the hero prefab. We could just grab that. Effects we don't need. None of this is needed. No props, no UI, no scenes, no scripts. We're going to write our own scripts. And we'll just grab all the sprites for the character. We don't need the environment. Maybe we'll grab the environment anyway if we want to add a little background. This is fine. We could just grab all this, grab all the sprites just to make it simple. Okay, hit import. We're going to grab one other sprite from the 2D pack, and this is where I just want to underline this point about the project settings. The 2D pack actually has project settings in it as well, and I think there may be a bug on the asset store where it's not showing that warning, because I actually had this happen to me the other day when I was prototyping this. So importantly, right, when we import this, we're going to go ahead and again hit none. So we don't get all of, you see these settings here, right? We don't want them. All we want from this is one sprite, which is going to be our coin sprite. So we're going to scroll all the way to the bottom, choose coin sprite.png and hit import. And we're just going to use this as our platformer coin. So important there, hit none, select the coin, and hit import. Okay, so now we've got the assets that we need. Let's go ahead and set up our player. So we'll go to prefabs, characters, hero, drop this guy in the scene, and you'll see there's some scripts that didn't load, right, because we didn't import them. We're going to remove those. We're going to write our own script. We're going to remove all the scripts. We're going to remove the audio source. And the rest of this is fine, right? So now what we've got is we've got a rigidbody 2D, which we're going to be using to add physics forces to the player to jump him around and move him around. We've got a box collider 2D, which is kind of the collider for the body. And then there's also a circle collider 2D, which is the collider for the feet, which has its own player physics material, right? So this is important. This is stuff that we want to preserve from the player. And then there's also the animator controller, which is going to play the little jump animations and so on. We're going to get rid of the bazooka. We can delete that. And we're going to get rid of the gun as well. And the rest of that should be good. Okay. And so now we're going to child the main camera to the hero and reset the position. Now notice we're just going to reset actually the X and Y position so it's centered on the player, right? So the camera is centered on the player, and we'll go for a little larger size, maybe 10, maybe 8, just a little more zoomed out, right? So the player's in the middle of the screen. The camera is focused on the player, and the camera will now follow the player around. There is actually a camera follow script, which you can take a look at if you want, but I found this to be nice and simple. And next, so that is good for the player object. Let's write our script. So we're going to create, in assets, we're going to create a new folder called scripts. And we're going to create a C# script, which we will call simple platform controller. I'm going to open that up in MonoDevelop. And let's get started. So we're going to start with our public variables. And the first two are going to be hidden. So we're going to type hide in inspector. So this means we can have a public variable, but not have it visible in the inspector, which is kind of useful. So we're going to, the first one is going to be facing right. That's going to be equal to true. So we're going to initialize that to true. And then we're going to have another one called jump. So facing right is just going to be, is the player facing right, which is how the player is going to start right. That's how the sprite is. And then jump is just going to be, it will be true for the frame in which the jump key, in this case the space bar, has been pressed. We're also going to have a public floating point variable called move force. We're going to initialize that to 365. And we're going to have a public float called max speed, and we're going to set that to 5. The max speed is the speed that we're going to kind of clamp our velocity to. So if the player starts to get above the max speed, we're going to force them back down to the max speed so they don't just kind of accelerate as we add force. We are going to add a public float called jump force, set that to equal 1,000. And we're going to add a public transform called ground check. So what we're doing here is we're going to be ray casting down to check if the player is standing on the ground, and or line casting actually, right? Because it's just in 2D. And then we're going to be doing that in the direction of this transform, right? And the transform is here, and it's just below the player, right? So the transform will be in the ground if we're on the ground, right? So then we'll cast down towards it and hit the ground, or if we don't hit it, right, it means we're in the air. Okay, so next we're going to have some private variables. We're going to have a private Boolean called grounded, and we're going to set that to equal false. We're also going to have a private animator called anim, which we're going to use to store a component reference to our animator. And then we're going to have a private rigidbody 2D called RB2D, in which we're going to store a reference to our rigidbody. I'm going to change start to awake and get our component references. So we'll start by saying anim equals get component animator, and RB2D equals get component rigidbody 2D. So just get and store our component references to our two components there. And in update, what we're going to do is we're going to cast our line down to see if we're grounded, to see if we can jump, right? So we're going to say grounded is going to be equal to the return value, right, of physics 2D dot line cast, right? So line cast and ray cast return a Boolean, basically if they hit anything, right? So we're going to set our Boolean grounded to the return value of our line cast. So we're going to check if we hit anything with the line, and we're going to do it from our start, which is a vector 2. We're going to use transform.position, right? And it'll just discard the z-axis. It's basically casting it to a vector 2. From transform.position towards ground check.position, right? Our transform at our feet. And then what we're going to do here, this is a little bit interesting. We're going to use 1 and the bitwise left shift. Basically, so we're just saying the only layer that we're going to be casting against here is the ground layer. And this is how we're going to express that. And then, so we're just going to cast our line against the ground layer. And then we're going to say if input dot get button down jump, and grounded equals true, right? So we can't double jump in the air. That might be a fun way to extend the script, right? But for now, we can't do it. We're going to check to make sure we're on the ground and the jump button has been pressed, and then we're going to set jump to equal true, right? In our physics loop, we're going to see if jump is equal to true and add our physics forces. So here we're just going to set the Boolean for the frame where the jump button was pressed and we were on the ground, and then we can apply the motion in our physics loop. Now, we're going to use something in our physics loop, so I'm just going to declare it now, which is a private function that returns void called flip, and this is basically going to flip the sprite around if we're trying to move. If we're trying to move right, it's going to flip the sprite to the right, and vice versa, right? So all we're going to do here is we're going to say our Boolean facing right is equal to not facing right, and you'll see how this is used in context in a minute. I just want to get it written so I can call it. Then we're going to declare a vector3 called the scale and set it to equal transform.localScale, right? So we're going to store our local scale into the scale, and then we're going to say the scale.x times equals -1. So we're going to multiply the x coordinate of our vector3, the scale, by -1 to flip it, to invert it, to make it positive if it was negative, or vice versa, right? And then we're going to say transform.localScale equals the scale. So we're basically going to flip, by scaling by -1, we're going to flip our sprite around, scaling the x by -1, multiplying the scale by -1. Okay, so now we're going to write our physics loop. So we're going to say void fixed update, right? We always want to do physics code within fixed update. And the first thing that we're going to do is we're going to say float h equals input dot get axis. So we're going to get our horizontal axis equals horizontal. Then we're going to set the speed of our animator. So we're going to say anim.setFloat speed, which is the speed parameter of our animator, and we're going to use mathf.absolute and pass in the value that we just got from horizontal, right, h. So basically, by using mathf.absolute, that means that whether we're moving to the left or to the right, our input.getAxis has a possible range of -1 to 1 as a float. And so by using mathf.absolute, whether we're moving left or right, we're going to use the positive float of that to set the speed, right? So we're not going to have a negative speed, but either one will set the speed so that we can basically speed up and play our animation when we move, right? The animation will play when we move is kind of the result of that. And it'll kind of ramp up a little bit as the input ramps up. Okay, next we're going to say if h times rb2d dot velocity dot x is less than max speed. So basically we're checking, are we under our kind of speed limit? Then we're going to rb2d dot add force. We're going to move, right? We're going to add force to the rigid body, and we're going to do it in the direction vector2 dot right times h times move force, right? So what's important here, we're only using right, but because h could be a positive or a negative number, if we're getting a -1 for h, then vector2.right is going to become left, right? So kind of little shorthand there, but that'll work nicely. Okay, then we're going to check if we've started going too fast. So if mathf.absolute, again, right, because we could be having a positive or negative number, right? We're going to say rb2d dot velocity dot x is greater than max speed. So we're checking if we're taking that positive or negative number, making it a positive number, and checking to make sure that it's not, or if it's greater than max speed, we're going to clamp the velocity. So we're going to set the velocity of rb2d directly. So we're going to say rb2d dot velocity equals new vector2 Now here, we're going to use mathf.sign, and that's S-I-G-N. Now what we're going to do is we're going to take rb2d.velocity, .x, and we're going to use mathf.sign. So what mathf.sign is going to do is it's going to return a 1 if we have a positive number and a negative 1 if we have a negative number, right, of whatever the velocity is. It's just going to give us a 1. So it's basically a way of figuring out if the velocity is positive or negative and using that in our next calculation, which is that we're going to multiply that by max speed. It's going to figure out which direction we're moving in and then multiply that by max speed to set us moving in that direction, but only at max speed. And then we're just going to set rb2d.velocity.y to be what it was, right? So we're just going to reuse the y velocity. We're not trying to change that. We're just clamping, basically, or setting directly the rb2d velocity.x. Okay. Next, we're going to do our flip. So we're going to say if h is greater than 0, right? Meaning we're moving to the right, and we're not facing right? Our sprite is not currently rotated to the right or scaled to the right, then we're going to flip, right? So we don't want to be facing one way and moving another. And then we're going to do the same thing in the other direction. So or else if, else if h is less than 0 and we are facing right, meaning we're moving to the left, but we're facing right, then we're also going to flip. Okay. Lastly, so we're just going to flip the sprite based on what direction we're moving in, right? Lastly, we're going to say if jump, right? If our Boolean that we set for jump becomes true, for the frame that it's true, we are going to add a burst of force moving up. First, we're going to say anim.setTrigger jump, right? So we're going to, we've got a parameter called jump in our animator controller, and we're going to set that so that we can transition to the jump state and play the jump animation. And then we're going to say rb2d.addForce new vector2 0 f on the x, right, and jump force on the y. And then we're going to set jump to equal false, right? So we can't double jump. And that should be good. Let's save that. Jump over to the editor, and we will now add that to our player. We're going to add component, hero, add component, simple platform controller. We're going to drag in our reference to our ground check. Very good. And let's make a little box for him to jump on. So we're going to actually create a 3D object, which you can use in 2D if you change the collider. So we'll set that there. We'll make it 10. And we're going to take off the box collider, which is a 3D collider, and add a box collider 2D. It's a little trick I didn't know about until recently. It's kind of handy. And importantly, right, we're going to set the layer to ground so that we can say, yes, this is the ground, and we can jump off it. Let's play. Boop. And now we push the space bar. The jump animation plays. Our guy jumps up in the air. He can flip back and forth, right? The sprite flips based on, you can see the scale, right? Inverting negative, positive as we're flipping. And so that is working pretty nicely. Let's add a little directional light here to just to light up our lives. And so next, what we're going to do is we're just going to get a little simple script here to spawn some platforms. Let's create an empty game object called spawn manager, and we're going to create a script to, and let's actually make a, let's label this ground and make a prefab out of it. Boop, drop that in prefabs, there we go. And let's write a new script for our spawn manager. We're going to go to create, C# script. We'll call it spawn manager. And there, open this guy up. And this is going to be a fairly simple script. We're going to have some variables, public integer max platforms, the number of platforms we want to spawn, which is going to be equal to 20. We're going to have a public game object called platform, which is going to be for the platform prefab, the ground. We're going to have a public float called horizontal minimum, horizontal min. We're going to set that to 6.5. We're going to have a public float called horizontal maximum, and we're going to set that to 14. So what these are going to do is we're going to be spawning platforms to the right of our first platform, and this is going to be the maximum distance to the right will be 6 units, and the minimum distance will be 6.5 units, and the maximum will be 14 units. So we're kind of deciding how far can we move the platforms from one another. And the reason I came up with these numbers is because that's kind of how far the player can jump. And we can tune it as well. And then we're going to do the same on the vertical axis, but in this case, so here we can only move to the right, right? It's either 6 to the right or 14 to the right. Here we're going to give the option of moving up and down. So we're going to have vertical minimum will be -6 and vertical max will be +6. So here we're going to allow a wider range. We could spawn above or below where the last platform was spawned by 6. And then we're going to have a private vector2 called origin, let's call it origin position. And then what we're going to do in start is we're going to set origin position to equal transform.position, right? So the first position will be the transform of the spawn manager. Then we can delete update. We're going to have a private function that returns void called spawn. And what we're going to do in that private function is we're going to do a for loop. So we're going to say for int I equals 0. And as long as I is less than max platforms, I++, right? So we're going to keep spawning platforms until we reach our max platforms number. And in here, we're going to declare a vector2 called random position. And that's going to be equal to origin position plus a new vector2, which we're going to create with our random numbers. So we're going to say random.range. And the minimum for that is going to be our horizontal min. And the max is going to be, you guessed it, our horizontal max. And I'm going to do the same on the vertical. So we're going to say random.range vertical, not you, vertical min and vertical max. So we're going to create this new vector2, right, which is going to be between our minimum and maximum values on the horizontal and the vertical that we created, and we're going to store that in random position, and it's going to be an offset from origin position, right, because we're adding that. So next, we're going to instantiate. So we're going to say instantiate platform at random position, right? Will be random position. No, random position is good, and then quaternion.identity, meaning no rotation. Next, we're going to set origin position to equal random position, right? So the next time we run the loop, we'll start from the last random position we created and then offset from there. So we're going to draw this kind of chain of randomly spaced platforms moving to the right and kind of varying in height, each one spawning offset from the position of the last. Okay, that should be good. Let's save it. Jump over to the editor. Let's see if we got any errors. Woo, jump. And then we're going to add that script, which was called spawn manager. We're going to drag in our ground prefab, and let's give it a test. The spawn manager, let's set the spawn manager to be at 0. Oh. Let's set everybody to be at 0. We're off in some weird zone here. The ground will be at 0, but just a little bit down. Oh, whoops, duh. Shouldn't have reset that. I should just reset the position. All right, the spawn manager is at 0. Okay, that should work. And let's see what's going wrong here. Spawn manager, spawning ground. Why is it not spawning? Nope. Oh, of course, because I didn't call spawn in start. There we go. Okay, so here, not quite. It's a little too high, so let's tweak that. We'll make the vertical max. Let's do between 5 and -5. It's a little off. Oh, actually, that's just because my... You know what? That was okay. Let's set this. It's just my first platform is just too low. I think that distance was actually okay. There we go. Woohoo! Okay, so we don't have any way to get rid of the player when he falls down, right? So we could write that real quick. But first, we'll write a couple things to make this a little bit more fun. We're going to make a C# script called platform fall. And what this is going to do is we're going to do public float called fall delay. Camel case. And we're just going to say void on collision enter 2D collision other. So we're going to check if other.gameObject.compareTag player, then we need a we're going to have a private rigid body, so we'll say private rigid body 2D RB2D and get a reference to that. Make this awake. So basically we're going to turn on gravity for these platforms and make them fall after the player has been on them for a minute. And we'll set that to 1 equals 1. So we're going to say RB2D equals get component rigid body 2D. And here we're going to say RB2D dot is kinematic equals false. So let's add a rigid body 2D, and we'll set it to kinematic, right? So that gravity scale is 1. That's good. Okay, so now what the RB2D. Oh, I forgot this. Forgot a parenthesis. Okay, let's see now. So when the player lands on it, this has to be of type collision 2D. Oh yes, of course. Try again. 1 Mississippi. Oh, and of course we need to add that script. And try it out. There we go. Okay, so we can see and of course apply it to the prefab. So it's a little too fast, right? Let's make it maybe 3. And of course apply. Oof. Oh, of course. So right now it's happening right away. So what we need to do is we're going to make another function, private function called fall. And we're going to invoke it. We're going to add a little delay here. So cut that. Move it here. I'm going to say invoke fall passing in fall delay, right? That was why I declared that delay and then I just didn't do anything with it. Invoke fall in fall delay after fall delay seconds, right? So now, yeah, there we go. It's waiting 3 seconds. So 1 second was actually a good value to begin with. I just wasn't getting any delay at all. So now we have our kind of, you know, pretty familiar platformer gameplay, but just making things a little more exciting by having the platforms fall when the player collides with them. Hooray, we reached the end. So let's just add in, we'll add in some coins and we'll add in a box to destroy the player when they fall beneath it. We could change, let's change the background color as well just to make it more juicy. A little kind of sky blue color there. And okay, maybe we'll make a little material for our boxes. We'll call this ground. And since we're in a kind of a Mario-esque mode, we'll make them a nice sort of Mario green color. Let's apply that. And let's get our nice coins going here. So we'll grab the sprites, drop a coin in. We're going to add a circle collider 2D. It's a little bit bigger. I think that's okay. Be a little more forgiving. And we're going to write a script for this. We're just going to write script, create C# script, coin. And in it, we'll just start with void. Let's make this a trigger so the player doesn't bounce off it. On trigger, enter 2D, collider 2D, other. If other.gameObject.compare tag player. So if it was the player that collided with this coin, we will destroy the game object. We could add score or play a sound or whatever later, but for now we're just going to destroy it. Let's just test that out. Oh, where was it? Oh, got behind something. Okay, and then wait a minute. Let's just move that up a little so it doesn't get blocked behind the, there it is. Oh, and I forgot to make it a trigger. Let's see, is trigger, yes. He's tagged player. What am I missing here? Just not colliding. Huh? Oh, of course I didn't add the script. As usual. There we go. All right, cool. So let's get these coins spawning. So we'll make another script called spawn coins. We're going to attach it to our ground, and we'll add to the ground some empty child objects. I'm going to put this one at x.25 and y2. We'll call this coin spawn 1. Duplicate it, put it at 0, and another one. Coin spawn 2, coin spawn 3 at negative 0.25. So just a couple of empty transforms that we're going to use to spawn coins at. We'll randomize them. So we'll go spawn coin, and then this is just going to be nice and simple. We're going to have a public array of transforms called coin spawns, plural, and we're going to have a public game object coin. In start, we'll call our function spawn, which we haven't written yet, and let's write that function. So we're going to say void spawn, and we can delete update. We don't need it. Oops. And then in here, we're just going to do another for loop. So we're going to say for int I equals 0. If I is less than coin spawns dot length. So we're going to get the array, get the length of the array, and then I++. So basically, as long as we're less than the number of transforms in our array, so potentially we could have different sizes if we wanted to, then we're just going to declare an integer called coin flip, set it to equal random.range between 0 and 2. So basically that's going to random.range excludes the maximum. So this is going to give us either 0 or 1. And what we're just going to say is if coin flip is greater than 0, basically if it's anything but 0, we will instantiate. So we're going to say instantiate coin at, so the prefab coin at coin spawns I. So coin spawns I dot position. So at whatever of the 3 transforms we're currently on in the array that we're looping through, we'll use that position, and then quaternion.identity. Okay, so just simple little random. We're going to have a 50% chance to spawn a coin at each of these locations. Let's lock the inspector and drag in our 3 transforms to our array. There they go. Unlock and drag in our coin prefab, which we need to make coin. And let's drag that in. And now we can delete coin from here. And there's 1 coin. Whoa. That was a little tough spawn there. Whoa. I touched it. Let's see. Failing. Grab that coin. Okay, something's going wrong here. We're not getting our... do I need to apply this to the prefab? I probably do. There we go. So we're getting some nice randomized coin spawnage. We can run along. The coins give you like a little incentive to not just run and jump to the next platform, right? It makes the game a little harder. Of course, we could add like a GUI to track the score, and so on, but I've done that in a couple of my recent sessions, so I'm going to leave that out of this one. Hooray, we won! And let's add a little trigger at the bottom of the level. Add a cube, give it a box collider 2D. Oh, sorry, remove the box collider. Add a box collider 2D. We'll move this down maybe -20. And set this to is trigger, and we'll set the scale to 100. Let's move it over so because we're gonna, our level's gonna go there. Oh, we can maybe even make it 500 just because. Set it to 250 on the X. Maybe make it 220 just so that the player can't jump off that way. We'll call this death trigger. And all we're going to do here is we're just going to say create C# script death trigger, and in here we're going to check void on trigger enter 2D collider 2D other, and then if other dot game object other dot game object dot compare tag player. So if the thing that collided with this was the player, we are going to do application dot load level application dot loaded level. So we're going to basically just reset the level, reload the scene that we're in. We need to save this scene as well. Let's save as, looks like I made a mistake. We'll save this scene as main, and then we should be good. What did I make? What did I do wrong here? Oh, again with this. So now, if we drop off, of course we don't collide for whatever reason. Death trigger needs the death trigger script. You can turn off the mesh renderer. Boop. Yeah. Now, if we fall. And actually, just for fun, I thought this was kind of fun while I was prototyping. Let's put the player kind of high up so you can't see the level when he starts. Falls down. And he just looks like he kind of just keeps infinitely. We could even make it less. Let's use the game view so we can see just above where the level is so that when he dies. Let me just check why the player is jumping. Let's take a look. Jump equals true. Grounded equals false. Jump. I think this needs to be false. Yeah. There we go. So now we, oh, and of course, because it's public, okay, that's annoying. We have to turn off hide inspector for a second so I can fix it. That's an annoying fact about hidden public variables. Okay. So now if we die, let's make it a little higher. I had this set in kind of a fun way before, so it just felt like we were just in this kind of endless loop. Yeah. It's kind of cool. Just keep falling down onto a new level. Hooray! So there we have it. Little simple. Okay, that didn't work very well, right? That we collided with the death trigger. It's got to be lower, -40 maybe. That's a little kind of design flaw in this, that it's possible for the random stuff to walk down there and have the player go into the trigger without being able to see it. It's a bug. But anyway, Not going to worry about it. Hooray! And so there we have it. A little simple platformer game. Hopefully this gives you some ideas for your own stuff. And thanks for watching.